Okay.
So for today's review, we're only going to do the Tuesday, Wednesday lesson. I know on Thursday I had switched the history of the periodic table lesson, but I'm actually going to recap that on Thursday just because this week you've got a very easy week. You have a whopping 2 single pages of notes to do. And so I figured we could talk about the board diagrams and talk about the periodic table more in depth this Thursday. So we're only going to be doing the elements and then the history of the periodic table in today's review. So on Tuesday, you guys would have looked at your notes on the elements. And so there are 3 main classes that we can sort our elements into. And those are metals, which are typically shiny and silver or gray in color. They're usually good conductors, so they pass along electricity really well or even heat. They're malleable and ductile, which means that they can be bent, they can be stretched out into thin wires, and so on. So another classification is the nonmetals. So these generally do not conduct heat or electricity well. They are usually brittle. So if you try to bend it, you're likely to break it. And they are not malleable. And they have little or no metallic luster. So they're not very shiny. Then the last one there is the metalloids. This is your smallest class of elements. And so these contain both metallic and non-metallic properties. Each of them will be slightly unique, which is why we can't really give you a general idea of what metalloids are. All we can say is that they typically share a little bit of the metal and a little bit of the non-metal properties. So looking here, here is our periodic table. So anything here in this gray section here is your metals. And so notice here that hydrogen is kind of really awkwardly off to the side here. And that's just the way that the periodic table was created. And I'll show you a fold up of it afterwards, or if you guys watch the video for the lesson, then you guys would know kind of the actual shape of the periodic table. You should know that it's kind of a little bit wonky, but the organization system is just beautiful. If you guys also watch the video on Dmitry Mendeleev. But anyway, so notice here we have, this one here might be hard to see, and especially on maybe the copy that you guys have of the periodic table, but there's what we call here a staircase. And so this one here is kind of a line that typically, if just in general, if you don't have anything labeled, you can almost separate that as metals and non-metals. And the closer you get to this staircase, the more likely you are to have a metalloid. But as you can see, that's not always the case, but it's kind of a nice way. All of your periodic tables will have some form of staircase here. I think they're over here, or sometimes they might be on this side here as well. But there's usually some sort of generalized way to kind of classify them. If you guys also watch the crash course video, you guys know that coming down here in these columns or groups, there is also way more specific groupings of the elements, and those are all based on the specific properties that they have. Say, for example, this last one here, this group here is called the noble gases, and they all exhibit very similar types of properties. So it's kind of cool. Kind of amazing when you look at, if you watch any history on Dmitry Mendeleev and even how he came up with this, and even just the history of the different versions of the periodic tables, it's actually really quite fascinating. So I'd recommend you guys maybe look that up in your spare time. Okay, so we also talked about elements and how we write elements. So they usually only contain 1 to 2 letters. There are a couple of our newer elements that might have 3 letters, but your first letter is always a capital letter, and then anything else that follows should be lowercase. And that's also how you know you have more than 1 element. If you see multiple capital letters, say in our first example, we have a capital C and a capital O, that means we have 2 different elements, which is carbon and oxygen. If we were to look at capital C, lowercase o, that is actually 1 element, which stands for cobalt. So do you see those 2 differences? The lowercase and uppercase is very important. So you have to make sure, say on your computer, your spell checker, if you guys are typing out your answers, you have to be very careful because your computer might try to capitalize or lowercase certain things, and you have to make sure you watch out for that, okay? All right, so then next we also talked about some common elements, and there were a few more listed, but I just picked out my top 3 favorites and very common elements that you might see. So the first one is carbon, and that is the element of life. So in all living things, in all organic things, you will have at least some sort of carbon atom in there, and it's usually connected with, there's usually a hydrogen, maybe sometimes oxygen, maybe sometimes a few other elements, but carbon is in all living things or things that were alive at one point. That doesn't mean that if something has carbon, it doesn't mean that it's living, but everything that is alive and that was once alive will have at least some, is made up of some part of carbon. Next one there that I thought I would highlight is hydrogen. This is actually the most common element in the universe. It's also one of the elements in water. So water is made up of hydrogen and oxygen, and the chemical symbol or name for that is H2O. So there's two atoms of hydrogen for every one atom of oxygen. So yeah, so it's the most common element in the universe. And if you guys remember back to your space unit, it's also a very important element in the sun and stars. And basically what part of that is what goes through the fusion to, for the nuclear reactions in order for this star to shine. Next one is oxygen. So our bodies need oxygen to survive. Plants need oxygen, and or they give off oxygen in their photosynthesis process. And it's actually the most common element on Earth. So make sure there's two different distinctions there. Oxygen is the most common element on Earth, where hydrogen is the most common element in the universe. Okay, so important distinction. The last thing we talked about was our diatomic elements. And so diatomic, if you guys kind of break down that word, di means two. So the atoms exist in pairs of two. So diatomic, there's two atoms. And so one thing that's really important is that this is only when they exist on their own. So if they were to be paired up with a different element, they might not necessarily have two. They might only have one, they might have three, they might have five. It just depends on what elements they're paired up with. But so by themselves, if you had just hydrogen, you would see it in a group of two. So we call it H2, meaning that there's two hydrogen. And so the next elements that are also diatomic are oxygen, fluorine, bromine, iodine, nickel, and chlorine. So those ones are all diatomic. And the acronym that I use, it was taught to me from my chemistry teacher, and I loved it. I loved it so much. If you guys remember at Halloween this year, I dressed up as Hofwrinkle the clown. So I was the diatomic element clown. It was the best costume I think I've ever made in my life. It's life-changing. I'm sure you guys may or may not remember that. But anyways, yeah, so that's diatomic elements. So they exist in groups of two on their own, and you can remember it by Hofwrinkle. So just remember here that little r here means that it's connected to B, so that stands for bromine. Just B on its own would be boron, so be very careful about that, okay? There's 7 diatomic elements. Later on, when you guys go into, if you guys decide to go into, like, say, chemistry 30 or even physical science 20, there is one other element. It's not diatomic, but it does exist. It can exist in multiple multiple atoms of itself, which would be sulfur. But that one is not in pairs of 2. I think I've seen it in pairs of 8. So we don't consider, we wouldn't consider sulfur as being diatomic. Okay, last little bit here is talking about the history of the periodic table. So we learned all about Dmitry Mendeleev's rather sad life. You know, his father died at a young age. His mother tried to put him through university. So in order to get money, she tried to get a glass factory going, and then a year later it burned down. And then, you know, she traveled across by horseback to different universities, where at the first one he was turned down, and then by the second one they did accept him. It's where his father went to university, and unfortunately shortly thereafter she died. So I mean, he lived a pretty sad life, but I think that in part drove his passion, that his mother really wanted him to do this, and so he did it for her. I'm sure that there was, he was interested in the subject, and he even was a little bit obsessive about it. But he had kind of a sad life, but I don't know if that's all the factors that led him to his greatness. So, but anyways, enough about that. So many scientists tried to find patterns and create an arrangement of elements, and it wasn't until 1867 that the Russian chemist and teacher Dmitry Mendeleev developed a system to organize the elements. So Mendeleev was so confident in his work and that in his organization system that he left gaps because he knew that there was elements that had not been discovered yet. So he looked at all these properties and looked at how kind of everything was related, and he was so certain that that there was missing elements that he left gaps. And what happened was that in 1886, germanium was discovered, and it actually fit into one of his missing places on the table. And he even proved a French scientist wrong about the data on a newly discovered element that he hadn't even examined. He said, this doesn't fit with my table and what I know about elements, so it has to be wrong. And it turned out he was right. It was amazing. So then the last little part, there's that in the crash course video, Hank explained the different groups or families, which is a topic you might talk about in grade 10, but for sure you'll talk about in grade 11 science, if you take the chemistry's little route. And that is, and I gave you guys the example at the beginning of, say, the last column in your periodic table is the noble gases. So they just experience or exhibit similar properties based on kind of where they are in that periodic table. So they're kind of really interesting there. So, but okay, so that is it. As I said, we're gonna do the history or the actual periodic table 101 in the next Zoom. So did you guys have any questions about the first two? You can either type them out, ask them.
I'm just trying to process everything. And
I had $1 for every time you said that.
Mm-hmm. We could retire.
Yeah. I joke. Yeah. But yeah, well, I mean, if it is a lot, I mean, feel free. You guys are allowed to message me on Remind about this, and we can either talk through Remind or we can schedule a Zoom and we can chat about what questions you guys have. Because I know that I do go through this. I mean, this is a summary, so it's meant to go by fast, but there is a lot of information. So, and when you guys look at the periodic table, like I'm just gonna look up here, like there's a ton of elements. We have 118 elements in our periodic table. It is overwhelming. The important thing about that though is that, you know, we are practicing. You guys are gonna do this in grade 9, you're gonna do this in grade 10. So the more that you work with the periodic table, the less overwhelming it is.